The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 1, Historical. Section 7, Equidistant Lines. It will suffice to give one other example of the attempts to base the theory of parallels upon intuition. Suppose that, instead of Euclid's definition of parallels as straight lines which, being in the same plane and being produced indefinitely in both directions, do not meet one another in either direction, we define them as straight lines which are everywhere equidistant. Then the whole Euclidean theory of parallels comes out with beautiful simplicity. In particular, the sum of the angles of any triangle ABC, figure 6, is proved equal to two right angles by drawing through the vertex A parallel to the base BC. Then if we draw perpendiculars from A, B, and C on the opposite parallel, these perpendiculars are all equal. The angle EAB equal the angle B, and the angle CAF equal the angle C. It is scarcely necessary to point out, however, that this definition contains the whole debatable assumption. We have no warrant for assuming that a pair of straight lines can exist with the property ascribed to them in the definition. To put it another way, if a perpendicular of constant length moves with one extremity on a fixed line, is the locus of its free extremity another straight line? We shall find reason later on to doubt this. In fact, non-Euclidean geometry has made it clear that the ideas of parallelism and equidistance are quite distinct. The term parallel, which in Greek means running alongside, originally connoted equidistance, but the term is used by Euclid rather in the sense asymptotic, in Greek meaning non-intersecting, and this term has come to be used in the limiting case of curves which tend to coincidence, or the limiting case between intersection and non-intersection. In non-Euclidean geometry, parallel straight lines are asymptotic in this sense, and equidistant straight lines in the plane do not exist. This is just one instance of two distinct ideas which are confused in Euclidean geometry but are quite distinct in non-Euclidean. Other instances will present themselves.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.